Okay, here's a second algebraic method for evaluating limits. It's called rationalizing. Um, so here's my first example. I want to just plug in an x. X equals 1. I'm taking the limit as x goes to 1, so try it. The problem is here that I have both a 0 in the numerator and a 0 in the denominator. That tells me I've got more work to do. I might have a limit. Okay. Now, this is already just linear, so I don't really think about factoring this. I'm going to do it again with some factoring, but when I do this one, I see the radical in there, and I think about being taught how to rationalize denominators. And actually, what I want to do here is I want to rationalize the numerator. I want to take this thing right here. I'm going to multiply this fraction by 1. I don't want to change the value, right? I want to figure out. I'm trying to figure out what the value of this limit is. If I change the value of this thing, I'm going to change the value of my answer. So I'm going to multiply by 1. That doesn't change the value. And then the form of 1 that I'm going to choose is I take what's called the conjugate of this expression here, that there's a minus sign in between, so I'm going to take it with a plus sign in between. And the reason that I do this is because when I multiply it out here, I'm going to FOIL the top out there. So that limit's equal to this. This is equal to the limit as x goes to 1. So I'm going to FOIL it out. I got a radical x times radical x, that's x. I've got a radical x times 1. I've got a radical x times minus 1. I've got a 1 times minus 1. Right? The denominator I'm not actually going to multiply out. I'm just going to leave it factored. The reason that I chose to take the conjugate is because when you multiply this out, these middle terms that still have radicals in them cancel out. You get a plus radical x and a minus radical x. So what I'm looking at here now is the limit as x goes to 1. There's just an x minus 1 left on the top. There's an x minus 1 on the bottom. And there's the square root of x plus 1 on the bottom. Okay. I know what I'm trying to do. I've got a 0 divided by 0. I'm trying to cancel that out. So I'm looking for a factor on the top and a factor on the bottom to cancel out. If I had multiplied the bottom out, then in order to cancel, I'd only have to factor again. Right? And the reason that I didn't multiply it out, I recognize that, hey, when x is going to 1, this is the factor that I'm going to try to cancel out. This is what I'm after. I'm looking for an x minus 1 in the top. Actually, I now have an x minus 1 in the top. So this is going to cancel with that. And you got to think this is multiplication here, so that was times 1. There's still a 1 left in the top up there once you cancel that out. And you've got this thing. So rationalizing did two things for us. One, it helped us find that factor we could cancel out, and it did put a new factor in the denominator, but it didn't put another 0 in the denominator. When I plug the 1 in now, right, there's a 1 on the top, I've got a square root of 1 plus 1, where the minus sign up here, the minus sign was bad, it made a 0. Well, I don't know if that's bad, anyway, it made a 0. Now with a plus sign, you've got a square root of 1 plus 1, which is going to be 1 plus 1, which is 2. And my answer here is a half. The limit as x goes to 1 of radical x minus 1 over x minus 1 is indeed a half. Okay. Let me do another example. This example will we'll kind of use both methods that we've talked about so far. I want the limit as x goes to 4 of x squared minus 16 over the square root of x minus 2. Plugging a 4 in just to see, I've got 16 minus 16 on the top. I've got the square root of 4 minus 2 on the bottom. That's definitely a 0 divided by 0, which means I definitely have more work to do. Okay. So I've got the limit as x goes to 4. I'm going to rationalize. I got this thing with a radical in it, so let me do that. I've got the x squared minus 16 over the square root of x minus 2. So this time I'm going to multiply by 1 in the form of square root of x plus 2 divided by the square root of x plus 2. Limit as x goes to 4. I chose this so that the denominator would be nice, right? So this is going to be an x minus 4 on the bottom, which makes me think I should probably be looking for an x minus 4 on the top. Well, there should be at x minus 4 because I plugged a 4 in, I got a 0 out. So let me factor that thing. That should be x minus 4 times x plus 4. And then I've got this extra now factor of radical x plus 2 up there. The x minus 4's cancel out. And now I'm ready to plug the 4 in again. So I've got 4 plus 4 times the square root of 4 plus 2. So this is 8 times 4, and I get an answer of 32. All right. There is, yeah, so there we go. I want to actually go back and do the first problem again a different way. So I'm going to write that down again and do it a different way. So yeah, here we go. Limit as x goes to 1. Square root of x minus 1 over x minus 1. Now there are some people who will just stick with the method I showed above, and that's fine. There's others that actually will like this method where even though that's a linear, you still think, hey, I can factor that thing. I mean, you can always factor stuff further. You know, even if you think 3 is prime, you can still factor it into the square root of 3 times the square root of 3. They're not rational number factors, but whatever. So I'm going to take this thing, and I'm going to think of this denominator as the square root of x squared minus 1. It's a difference of two squares that does factor into the square root of x plus 1 times the square root of x minus 1, right? That if I recognize this, I'm thinking in terms of a squared minus b squared, and I can factor that into an a plus b times a minus b. So it's just a matter of recognizing that x actually is the square root of x squared. It is an a squared, and you can factor like this. Then you've got those things that cancel, leaving just a factor of 1 on the top. And this looks a lot like what we just did. Plugging the 1 in now, I've got a square root of 1 plus 1, which is 1/2. Okay. If you're comfortable with factoring like that, feel free to do so. If you're more comfortable with rationalizing like we did in the first example, then by all means do that. Either way works.